Debjyoti, I heard you say again and again, AI is only as good as the data it can leverage. Why is that so?
That's right, Andy. Actually, AI is actually inseparable from the data. And let me simply put it in 2 points. So dependency of AI models on data plays out on these two fronts. Number one, the AI models need clean and accurate historical data, usually in substantial volumes to train, in order that these modules are effective to predict with accuracy and reliability. When we are talking of AI carrying out real-time predictions, and this is the second part that we are talking about. This is AI agents are carrying out real-time predictions to help in decision making. They need to be served event data in real time with the least amount of latency and with absolutely very high consistency. So think about an AI agent designed to act autonomously, making decisions and taking actions with minimal human intervention. It probably focuses on a goal-oriented task like keeping a production process tuned to the maximum efficiency. The recommendation prescriptive actions that this agent is supposed to provide would be continuously adapting to the changing environment. So the data integration, the pipeline kicks in here. It provides the right data at the right time to this AI agent to then make the prediction.
All right, so taking it from there, what are the highlights regarding data integration functionality in mcube 5.2?
So here is an infographic which describes the data management capabilities of mcube 5.2. So firstly, it is a no-code data engineering, which is actually very highly contributing to the productivity. Then this data management engine is actually a multi-engine pipeline. So you can have row-based processing, you have cluster computing using bulk data, in-memory computing. So you can adapt to the demands of the workloads of the processing which is required in order to frame the pipelines. The entire end-to-end pipeline management is automated and it is scalable. So it can very seamlessly scale depending on the workloads. The pipeline has cloud native architecture, so that means it is deployable on any cloud and it can connect to data sources, whether in the cloud or on premise, and very seamlessly process the data and bring it over to, as you can see on your right side, there is the lake house, the data marts where the data are being fed. The pipeline management among many data engineering users, it can be collaborative and people can work on these building these pipelines together. So that is another productivity enhancement that this tool brings along. And finally, we are talking about the real-time capabilities. And as I already mentioned, for real-time agentic AI to work, you need real-time data to be fed into them. So that's why if you look at what this data management tool does is it brings data into your lakehouse, it brings data into your marts, it can connect with the semantic layer and add to the context. And this has been spoken about by the speakers who came before me. And finally, the real-time data pipeline feeds can go directly to the AI agents. And to wrap up the whole thing, this entire operation and the functionality is very neatly encapsulated, offering the premises of data quality, providing the security and access to the data, having a full end-to-end governance process built in, and obviously the connectivity to the semantics. That in short would wrap up the data management capabilities of mcube 5.2, Andy.
So if we look at this from a enterprise class AI deployment at scale point of view, if we try to put on that lens in front of our eyes and look at how we are moving forward, how do those integration capabilities uniquely position mcube 5.2?
Well, I would say I would point out one illustration here, and here I'm going to illustrate why this is unique. So what our data management capabilities do is it is actually tying up two things, the semantics and the AI. So in fact, it's a trifecta of the data management, the semantic layer, and the AI, which makes this proposition very unique. And this is another infographic which is trying to illustrate the case that I'm talking about. So the real life world is represented, by a certain behavior, the process behavior, which actually is typical under different scenarios, or let's say the working envelopes. This behavior of the processes is actually what is contextualized and stored in the semantic layer. Now, when a real-time feed comes in, and it is received by, let's say, the first agent, which we shall call a decision agent, and this agent's job is to decipher this real-time feed in the context of what kind of a performance envelope is this feed coming out of. And depending on this, it can then take the decision to route it to the right optimizer agent. And here we are talking about, there are three different agents, as you can see at the next layer, and which actually are running different models which pertain to the different operating conditions. So routing this data to the right optimizer model is what results in the correct decision or recommendation to be done. So that's what the little flow here of an autonomous AI agentic workflow ends with the actual instructions or the feed going out to the outcome processor, which can be, let's say, a warning message, or it can be a feed to an APC, that's an automatic process controller, to actually correct the process. But whatever it is, in the situation that in a real time there's an autopilot which is continuously monitoring where the process is headed and where it should go, this interaction between the contextual semantic layer and the real-time feeds and the decision-making capabilities of the AI agent is what makes this entire process absolutely effective.